Hello everyone, I am Chandana. I am currently pursuing my first year engineering in Sri Venkateshwara College. Today I am going to give a presentation on vector algebra. Let's come to the introduction to vector algebra. Vector algebra deals with mathematical operations on vectors in a vector space. Vectors have both magnitude and direction, make them distinct from scalars. Common operations in vector algebra include addition, subtraction, scalar multiplication, and dot product. Let's see the pictures here. Addition, connect head to tail, and subtraction, click the arrow head, then connect head to tail. Vector representation. Vector can be represented geometrically as directed line segments in space. In Cartesian coordinates, a vector is represented by an ordered set of numerical components. Unit vectors such as I, j, k represent the direction of the coordinate axis. Let's come to the law of vector algebra. If a vector is multiplied by a scalar, as in, then the magnitude of the resulting vector is equal to the product of p, and the magnitude of and its direction is the same as if p is positive and opposite to if p is negative. Vector algebra is used to find the interplay of two or more quantities in physics. Scalar triple product of vectors is the dot of one vector with the cross product of the other two vectors. If any two vectors is in a scalar triple product are equal, then the scalar triple product is zero. Let's come to the types of vector. There are 10 types of vectors in mathematics, which are zero vector, unit vector, position vector, co-initial vector, like and unlike vector, coplanar vector, collinear vector, and at last equal vector. Let's come to the vector addition. Vector addition involves combining two or more vectors to form a resultant vector. The parallelogram law and the triangle rule are commonly used methods for vector addition. The resultant vectors is a diagonal of the parallelogram formed by the original vectors. And vector subtraction. Vector subtraction is a process of finding the difference between two vectors. To subtract a vector, reverse the direction of the vector to be subtracted and add it to the first vector. Geometrically, vector subtraction is equivalent to adding the negative of a vector. Let's come to the scalar multiplication. Scalar multiplication involves multiplying the vector by a scalar quantity. The magnitude of the vector is multiplied by the scalar while the direction remains unchanged. Scalar multiplication can stretch or shrink a vector without changing its direction. And let's come to the dot product. The dot product of two vectors is a scalar quantity obtained by multiplying their magnitudes and the cosine of the angle between them. The dot product is commutative, distributive, and can be used to find the angle between two vectors. The dot product is used in physics, engineering, and mathematics for various applications. Scalar or dot product of two vectors. The scalar product of two vectors is written as A and A dot B. It is also called the dot product. A dot B is equal to AB cos theta. Theta is the angle between the A and B. Let's come to the cross product. The cross product of two vectors result in a vector that is perpendicular to the plane containing the original vector. The magnitude of the cross product is equal to the area of the parallelogram formed by the original vector. The cross product is used in physics and engineering to calculate torque, magnetic fields, and angular momentum. Let's come to the vector norm. The normal of a vector is its length or magnitude and is denoted by uh, modulus v. The Euclidean normal of a vector is n-dimensional space is calculated using the Pythagorean theorem. The normal of a vector is always a non-negative real. Let's come to the applications of vector algebra. Vector algebra is used in physics to describe quantities such as force, velocity, and acceleration. Engineering applications include analyzing forces, moments, and electric fields. Computer graphics and 3D modeling rely on vector algebra for transformations and rendering. Here are there some examples for scalar quantities and vector quantities. Scalar quantity has only magnitude and vector quantity has both magnitude and direction. Scalar quantities, here are examples: length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, power. And vector quantities are displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and weight. And at last, let's come to the summary. Vector algebra is a fundamental branch of mathematics that deals with operations on vectors. Vectors have magnitude and directions and can be represented geometrically or algebraically. Understanding vector algebra is essential for various fields, including physics, engineering, and computer science. Thank you, everyone.